Hello students, welcome to Easy Engineering. This video I'm going to explain you the time domain specifications in unit number 2. So for any control system, the desired performance and characteristics are specified in terms of time domain specifications. See, whenever the energy storage elements of capacitors and inductors are subjected to any disturbances or subjected to any inputs, these elements can't respond instantaneously and they exhibit some transient response. Transient response means the time varying responses. So, the transient response of a system to a unit step input depends on initial conditions. So, to compare the time response of various systems, it is necessary to start with standard initial conditions. The most practical standard is to start with the system at rest, and so output and all time derivatives before t equal to 0 will be 0. This transient response of the practical control system exhibits damped oscillation before reaching steady state. The transient response characteristics of a control system specified in terms of these following time domain specifications. Delay time T suffix D, rise time T suffix R, peak time T suffix P, maximum overshoot or peak overshoot M suffix P, settling time T suffix S. We'll see all the explanations one by one. So for this, consider damped oscillatory frequency means damped oscillatory response of second order system for unit step input. With this oscillatory response, here the author explains all the time domain specifications. The informations are referred from Control Systems A.Nagoorkani book. Now observe the diagram. Damped oscillatory frequency T in x-axis and C of t controlled output in y-axis with a reference 0. TD have an half the response time, rise time have the full response time, and whenever the response reaches an peak, that particular time is an peak time and the difference is an peak overshoot, and settling time when the waveform is going to be settled. We can't be predict over, so it have an allowable error with 2% or 5%. This is the thing. We'll see one by one with an explanation. So delay time is a time taken to reach the 50% of the final value. See here, 50% of the final value. But the important point we need to notify is an important point is at very first time. Then rise time is a time taken to rise from 0 to 100%. So it varies for all the systems, undamped, underdamped systems, one by one. For underdamped system, it has an variations of 0 to 100%. For overdamped system, 10 to 90%. For critically damped system, 5 to 95%. But for the sake of an rise time derivation purpose, you have to take from 0 to 100% of every first time. See here, 0 to 100% of 0 to 100% of every first time. Then peak time and then peak overshoot. Peak time is a time response to reach peak value at very first time. Peak value. Then peak overshoot or maximum overshoot is the ratio of peak value to final value. So the peak value to final value, where final value as C infinity of C of t. C infinity, which is a final value of C of t. Maximum value is CTP, means maximum of C of t. So the peak overshoot is equal to CTP minus C infinity by C infinity into 100. Then settling time. Settling time is a response when to stay within a specified error is a settling time. So as an examination point of view, you have to describe like this: is a time taken by the response to reach and stay within a specified error. The specified error is denoted with a percentage, either 2% or 5% of final value. So these are all the time domain specifications. You just understand the definitions and the timings. All the timings are given expressed in seconds. Peak overshoot only expressed in percentage. So in this aspect, all the derivations we will see in the next video. Thank you, students.